Hello and welcome everyone. Thank you for joining us today. We'll begin the presentation shortly, and this is Suma Pannam. I'll be your moderator for this session today. And Q&A questions, you can type them either in the chat by clicking on the tab Q&A, and also we'll have dedicated time at the end of the session. And it's all yours now.
Oh, it looks like Suanne might be first a little bit.
Yeah.
I'm sorry. Let me try to get... Erica, Harvey, I can see that you're in the people. If you can request that you have video and voice, you should be able to get in here with us. There we go.
Oh, good. Could you hear me?
Yep, I can hear you now.
Thank you.
Well, since Suanne's gone, let me go ahead and try to pull up the PowerPoint myself, and I can get us going at least.
Good morning.
All right. All right, Erica, would you like to start?
First introducer. Go ahead, Sean.
Okay. Well, I'm Sean Harwell. I am the First2 grant assistant at Fairmont State University. I'm here with Suanne and Erica Harvey to talk to you today about some of the improvement community things we've been doing. Go ahead.
I'm Erica Harvey. I'm a professor of chemistry at Fairmont State University and the PI, one of the PIs for First2 Network, which is a statewide grant in support of student success. And we think that we lost Suanne. And since this is a new platform, I'm also not sure if Sophie is are you another, can you talk, Sophie?
I'm just a viewer. I didn't know if you guys wanted to see your people or not.
We would, if you have enough bandwidth, we would love to actually see and interact, especially if maybe, I can't tell if there are other people who just didn't request video access, or if maybe you're the only person who's here, then we can change the conversation.
I don't know. I do want to let you know that, Erica, I actually know you. I went to Fairmont State University and worked for Deb Hemler.
Oh, Deb also is involved in First2, and Sean has been working closely with Deb. Wow.
Yep, I actually worked with Sophie at the coffee shop in the library at Fairmont State a long time ago.
Oh my God, seriously?
Oh, and Emily says there's only, the way this works, there's only 5 presenter slots and there's 14 more people in the audience. Sean, can you see that, or can you figure out, maybe it's under people?
Okay, I can see in the top, it says 5 out of 5.
Yeah, I think so.
So I guess I took like a presenter slot then?
It's fine. I mean, I would have expected that we'd all be able to talk. That's sort of what we assumed. But so that means people will need to put questions in the chat, and we'll try to be very responsive to the chat. So please stop us if you get to a place where anything doesn't make sense. We will not feel bad about that. We're all learning this technology together. And welcome to everybody else who's here. Thank you, guys. Did Suanne come back in? I know Suma is probably trying to as well.
No, I don't see her in yet, so.
Okay, well, without Suanne. Suanne is, and thank you, Sean, so much for running the PowerPoint. Suanne is another PI for First2 Network. She is at Green Bank Observatory, and I believe she will be joining us. We had her a little bit earlier this morning, and then she disappeared just before the session started. And if you are interested in First2 Network, that first2network.org, and you can learn much more if you're a kind of person who likes to look while you're listening. Sean, do you want to go to the next slide? This was our plan for today, recognizing that technology can do weird things to you. I want to tell you a little bit about the first. Oh, and Suanne is on her way back. What is the problem that we're trying to solve with first generation rural persistence? STEM? Suanne, can you talk?
I can. Can you hear me?
We can.
Oh, good. My internet just completely went out. Can you believe that?
Yes.
Yes. Go ahead and finish this slide, and then I'll take the next one.
Okay,
right.
I'm just sending
because you are either familiar with improvement science or interested in improvement science, because it featured heavily in the description. So we'll talk a little bit about what that is and how we're using it in First2 Network, basically the scientific method. We'll give you some examples of improvement science cycles that we're working on in the, and have a time for you to think about what related to STEM student persistence might be in your control, and that you might be able to have change ideas. And Suanne, we have about participants under people.
Yep, I see that. Welcome, everybody. You can move on to the next slide, and I'll just say hi. I'm Suanne Heatherly, and I'm one of the PIs on this First2 Network adventure that we are on. I'm really glad to have you here, interested in what we're doing and maybe thinking of ways to contribute. You want to go to the next slide, Sean?
Did you want to go over to, because I didn't really explain First2, and that was that last slide, Suanne.
Yeah, right. Well, I think the next slide kind of talks about the problem that we're trying to solve. The First2 Network is a National Science Foundation funded program that we hope exists well beyond this funding, where we are really interested in improving the persistence of STEM undergraduate students in our state. And in particular, we would like to focus on rural first generation students. And we're taking students as they are, as they're entering college, who have professed an interest in being a STEM person, a scientist, an engineer, a technician, a computer programmer, whatever it may be. So these are students that have left high school, they're interested in being a STEM person, and still so many of these students fail to succeed through the undergraduate education and end up with a degree in STEM. So I'm still not seeing the next slide. And Sean, you're advancing these, right?
Yeah, are you seeing the problem slide? Or do you want the one after?
No, I'm not seeing the problem slide. I'm seeing the presentation overview slide.
Okay, can everyone else see the problem slide, or is it still stuck on that same one for everyone else?
I see the problem slide, and I saw you.
Okay.
Good. All right. Well, I'm looking at it on my screen, so this will work for me too. So if you want to move on to the next slide, then one of the first goals in improvement science is to really understand the problem. So we're saying here that West Virginia students have a problem succeeding through that undergraduate degree, and it's in the first 2 years that the problem is really big. So digging into that problem, we actually draw from 3 different sources. One is from the literature. What does the literature say about rural students, rural STEM students, first generation STEM students? What does our own research tell us? So at West Virginia University, we have a research team that's been digging in to our own population of students. And then we need to listen to the students themselves, or else we're not going to get anywhere. The students are the ones that are experiencing the issues and the problems within our institutions, and their voice is really central to our work. So if you want to move on to the next slide here, if you look into the literature on rural student success and persistence and first generation student success and STEM students, number one, we have to tell you that there's not a lot of literature there at all. So in doing our literature search in the beginning of this, we ended up with sort of two columns of things there. On the left-hand side, we have the general culprits. What are the general culprits to persistence as an undergraduate STEM student? And then on the right, there are some rural factors. And so you see that lack of family knowledge about college, lack of understanding how to navigate college once you get there. These are the general culprits that impact all first-gen students, whether they're STEM students or not. Students being surprised at the work level and the course rigor and faculty expectations is a big problem. But on the rural side, we have things that are both strengths and weaknesses, I guess you could say. Students that are rural have really strong family and place attachment. Their community has been a big source of their affirmation in their growing up years. And that can compete with, being in college, particularly being in a big university like West Virginia University. They have lack of experience with large campuses and diversity, and just underestimating the need to build relationships with their faculty, to be proactive about that with students that are further along than they are, just build a network is something they're unfamiliar with. And they're more likely to need to work than non-rural students. They're more likely to need to take on a job, which can distance them from campus life and community life and getting that help that they need. In the next slide, though, our own research is telling us something about rurality in West Virginia. It's like we're all part of the same culture in a way, whether you're from Morgantown or Charleston, which we consider sort of the more urban areas, I'll put that in quotes, or whether you're in Pocahontas County like me, which is one of the most sparsely populated counties in the state. We seem to share a culture. And so the federal designations of rurality are not enough really to explain what goes on in our state. And so some of our researchers have been digging into what it means to live in certain parts of our state and whether that has an impact on your ability to persist. So we know that your college GPA is probably the biggest factor in determining whether you're going to stay in a STEM degree, transfer out of that degree, or leave college altogether. And things can impact that. And what we're finding is that you can kind of cluster our counties by the opportunities, the museums, the libraries, the events, the cultural opportunities that are there, in addition to population. And when we do that, we can kind of cluster the state into three different areas. And we find that although the effect is not great, it still is an effect, that a lack of civic facilities has an effect on AP credits earned by students and available to students, and their high school GPA, which in turn has an effect on college GPA. So if you're in a location in the state where these opportunities to do STEM in other contexts besides school or to take additional dual credit or AP classes can have an effect on your college persistence. And in the next slide, this is digging into, WVU has a huge, institutional database of students and lots of properties there. And our quantitative team has been digging into that institutional data, which is very, very rich indeed. So from our own research, and you're going to have to maybe click a few times for us, unsurprisingly, math entry point is a really big predictor of college success for those students that are in physical science or engineering type majors. And if you click through and see the first chart there, you can see that if your math entry point in college is algebra, you're only 30% likely to graduate with a STEM major. If you've declared a major coming in and you enter as an algebra student, only 30% chance that you might get graduate with STEM major. Whereas if you enter and you're Calculus 1 ready, your chances go up to 70% of graduating with a STEM major. So if you take a look and dig in a little bit to who is coming in at an algebra ready level versus a calculus ready level, you will see that, I'm sorry, my dogs are going to bark here. Sorry. You'll see that first generation students, 37% of first generation students enter at the algebra level, which is a problem for them. And rural students, if they're very rural, 42% of those enter at the algebra level. So that's kind of a, an obstacle against success coming, right into the gate as a college student. And then if we look at what our students say, so if you go to the next slide, and eventually some Post-it notes will come up. Our students, our first generation students that we work with, we ask them, what's happening, what's going on? And we find that our students feel a pretty remarkable imposter syndrome once they've gotten over the initial, elation of being a great student in high school and going to college to pursue their STEM dreams. And then the reality hits and they experience imposter syndrome. And that impacts them a lot because it means they don't visit, their professor when they need to. It means that if they get a bad grade, they're completely demoralized by it, don't know what to do about it, and may shut all that down, which impacts their GPA and so on. They also tell us that, they can't really talk to their parents about being a computer science major or something. They don't get it. Their parents who didn't go to school or go to college, it's hard for them to talk about their major and tell them what's going on. And they even tell us that even though they were honor students or took AP classes in high school, that they weren't prepared for college level work once they get here. So these are just some of the things that students who have been through a year or so of college as a STEM major have been telling us about the obstacles that they face in our institutions. So not only do they need to do a better job of, let's say, time management, but our institutions need to do a better job of figuring out ways to improve the culture, the experience of students, so that some of these obstacles go away. And that's where improvement science really comes in. So if we take all these things that you've just seen here and go to the next slide, I'm going to scare you to death with this one because this is called a fishbone diagram. It's part of improvement science where you really diagram all the root causes underneath, big chunks, big obstacles. And this is what we came up with as part of the exercise of First2. And I think Erica is going to make sure that you have, down at the bottom of this slide, she'll give it to you as well, to see all the different bones on the fish, all the different smaller granular pieces underneath these that we've come up with. And honestly, I'm sure that you could add to this because we haven't captured everything. So once you create a fishbone diagram like this, then you try to pick the ones that you think you can affect change on and that might move a lever to push toward more students persisting in their STEM majors. So you would pick ones that you think you could hypothesize would have an impact and that you can change yourselves. And that becomes the next phase of improvement science. Do any of you guys want to say anything else about this crazy fishbone diagram while people are looking at it?
Well, looks like Erica just made it back in. So.
Okay, cool. All right, let's move on to the next slide briefly then. So once you kind of pick the areas that you want to concentrate on in improvement science, then, which we did, we have working groups that kind of devote themselves. They're all across the state. They're not just from one university or college or sector of folks that are interested in our STEM students, but it's across sectors and across the state to work in these 4 areas. So these are our drivers for change. So we have student voice is in the top left there. Our students identifying issues that impede their success and helping us create those solutions. So we have our undergraduate students make up about half of our network. The engagement with STEM process and community, I think Erica's going to talk about that a little bit more, but getting students into that community, that STEM community that they want to be a part of early and often is a really important thing that we work on. And then we want to make sure that our STEM students access our faculty and support services and each other to engage with their institution, because that's a predictor of success as well. So we're going to give you 3 examples of some improvement work that we're doing. So these are places where we think we can make a change. We are trying changes, and we are analyzing the results of that in a pretty rapid fashion. Improvement science is the scientific method, but it's not long-term. It's not like a year-long research project. It's meant to be quick and actionable, and you can see a change is moving you in the right direction or not, and then you iterate on that change. So it's supposed to be sort of an embedded, easy to do, easy to measure way to say, can I make a little change here and will it have the desired effect? So we have 3 that we're going to go over with you. Sean's going to talk about our West Virginia STEM Hub dashboard that we're creating. Erica and I will talk a little bit about this immersing students in the STEM communities of practice. And then Erica is going to talk to you about a mental health awareness idea that is having some really promising effects as well. So I will turn it over to you, Sean.
All right, thank you. All right, so as Suanne had mentioned, we've been working on the West Virginia STEM Hub dashboard, and so what we want to use this for is to be able to give students and people around West Virginia more STEM opportunities. You don't always know what's going on around your state or what's around your community, and finding those STEM opportunities for your students, your children, is really important. So I'm going to see if I can drag over here some of the things we're using in this tool. So we're trying to make this a one-stop location. You come here, there's a bunch of different tabs, and you can find these STEM resources throughout West Virginia. We're trying to collect all this information through Qualtrics database. We've been working really hard to refine that and get it in a good place where it's not too much of a burden for everyone to fill out. And so we're hoping that we can get a lot of people supporting this database so that it gives opportunities to everyone around the state. We're in the late stages of development. We have, I'd say, probably about 90% of this done. We're really trying to fine tune it and just get some extra features in there to help everyone be able to filter through all the opportunities and find exactly what they're looking for. So right now, we just have to refine Tableau. So at this point, we are using Qualtrics to gather all the data, Tableau to display the data, and we are also using the programming language R to take the data in Qualtrics and manipulate it in a way that it makes more sense to the consumer. So then we're also trying to advertise. One other reason we're here, try to get more people to insert their resources into that database, and then figuring out the maintenance of how we're going to keep this going. So I'm going to go ahead and go to the next slide. And this slide, if you scan the QR code, it'll take you directly to our website and the location of where the current dashboard is. These are some pictures. I'll try to bring you over directly to the dashboard, but this should be the first thing you see is this big map of West Virginia. It has dots of where all these different resources are located, and it has different filtering options by subject, types of organizations, and has links to their websites as well, so you can go and look more into those resources. Now, this big starry sky, we had a vision of what are we going to do with the virtual events. So we thought, well, they're virtual, they're just kind of out there in space. So we just put a little Milky Way background. They're kind of all lined up there against the Milky Way. And so we're working on that. That's not in the dashboard quite yet. We're still working on how that's going to be filtered and a little bit maybe better colors so they don't all blend in quite as much. But let me see if I can go ahead and pull over this dashboard so I can show you in person what it looks like. Okay. Oh, great. And I can just pull this over. So this is our website, first2network.org. Just a small plug if you want to use it. But if you go over to this resources tab, you can see that the West Virginia STEM Hub dashboard is right there. You can go ahead and look at it whenever you want, insert something. So it has all these different tabs. If you need a different view of this, the direct link is up here, but we do have it embedded within the web page so you can go and look at everything. We have the different filtering systems. You can see you can zoom in and out on your state. We can pick a different subject if we like. Let's say we just want to go for computer science and technology. It'll filter it down and show you these different resources. And of course, it has their website over here on the right side, so you can just click that and go to their website. We also have a cool, fun visual tools to go along with it. We have this Hub Stats page that'll kind of give you an overview of the different available resources that are in the database at that time. If you want to look at a more traditional view, we just have a list view so you can filter it and go through that way. And then, of course, we have the survey embedded directly into the dashboard so you don't have to go anywhere else to fill out your resources. This is the current version of the virtual events. Doesn't look quite as happy and as fun as the space diagram. And then we also have an FAQ page that's going to be coming up in case you have any questions or concerns. You can go through here and look and see if some of those answers are in there. And there's also a feedback section in the Qualtrics form. So if you have any suggestions for the form or anything for us to add to that FAQ document, it's greatly appreciated. All right. So that's all I have on the database. So I'm going to go ahead and flip it to the next slide. All right, and is Erica back for this one?
I don't see her.
I don't see her either. Suanne, would you like to go, or I can try to muddle through it? I see you're muted, Suanne. I'm sorry, I can't hear you.
Hear me now?
Yes, I can.
Okay. Are we on the getting into a STEM community of practice?
Yes.
Okay, cool. Hang on a sec. Don't know why that's there, but get rid of it. Okay, so the second example that we'll go into here is one that the literature tells us is a promising practice, that it has an effect, and that is getting our students into a STEM community of practice sooner rather than later. I work at an observatory and we offer a summer research experience, but they're typically juniors or even seniors. So they've already survived their first 2 years. And that's when the major attrition happens. So we're trying to do this earlier on. And we also are trying to educate our research mentors that younger students can actually be really productive co-researchers in a community of practice. So if we go to the next slide here, what we do is we offer 2-week bridge experiences that are really focused on STEM research and learning about your professors and getting to know them and getting to know upperclassmen that'll be going to your school and things of that nature. And we find that by embedding students for 2 weeks in a research environment, if they come to Green Bank Observatory, then they're going to be working with some data that actually needs to be looked at. If they go to Fairmont, they might be creating new substrates to try to split water and catalyze the creation of hydrogen or something like that. So these are real authentic experiences, but more than that, they bring together upperclassmen who've already been through a year or two of college and the professors themselves in a more of a camp setting in a way that hopefully removes those barriers and builds those relationships that we think are really important. And our pre-post tests tell us that students have an improved STEM self-efficacy. They have more well-deserved confidence in their ability to conduct the work of a STEM person. And they also feel more of an identity, not only with their institution, if the internship happens there, but with the people with whom they're going to be working as a student in the coming months and years. So the next slide, though, is going to show you an improvement science thing that we're doing with this immersive experiences. And that is to give mentors, undergraduate students, upperclassmen, a real leadership role in providing content during that 2-week immersive experience. So we hypothesize that new students need to build a network and a sense of belonging with their fellow STEM students, that's probably going to help them succeed more than, a tutoring center somewhere, even if they have students that they can go to. And our hypothesis is that students will say that their undergraduate mentors were really valuable to them. And so our change idea is that our mentors, our undergraduate mentors, are going to be given that leadership role of developing and leading activities, some of which are instructive and some of which are just social and fun. And if you go to the next slide, you'll see that in purple, this is our internship, 1 week of our internship last year when we were completely virtual. And so this is just our daily schedule. And the purple, I just want you to notice the purple bits, because those are places where mentors were in charge. So every morning at the start of every day, they were in charge of designing an activity, giving lots of attention to the students, and then generally at the end of every day, something social and fun, and then instructive things throughout various days as well, like what it's like to be in college and how to find services that you need and so on. And so if you go to the next slide, what we did was every day we asked a couple of questions of our students, and this happened not only at Green Bank, but at 9 different sites last year, where we asked our students whether or not what their favorite activity was, and to what degree did the activities help them get to know their faculty better and help them feel more comfortable with their peers and make friends, because these are 2 predictors of persistence. And so you can see from the pie chart there that mentor-led activities were, in fact, the most popular, followed by STEM lectures. So when faculty were telling them what they needed to know to do their research, that was also very popular. And on the right-hand side, you can see that between asking the question the first time and asking the question a second time, 5 days later, we see that the activities that they're participating in are helping them get comfortable with their faculty and helping them get comfortable with their peers and make friends, even in a virtual setting. So we know that mentors are really important, and undergraduate students with a little bit of STEM under their belts are really important to our baby students, our up and coming freshmen. So that's the immersive experiences thing that we do. And then just a little, just to show you what that improvement science looks like. It's easy, right? Ask a couple of questions, see what the response is, see if you think that's moving you in the right direction toward improving the culture that the students will be in as an undergraduate STEM major. Is Erica back yet?
I have not seen her, no.
Okay. So hopefully the next slide says building mental health awareness.
It does.
Okay. So this PDSA stands for Plan, Do, Study, Act. That's sort of the cycle we use in improvement science. And this PDSA that I'm going to tell you about next came from listening to the students themselves. Back in the spring of 2020, and I see lots of great sessions happening in this conference about, how did we cope with that and what has it taught us about going into the future? So in 2020, we asked our students, who were really struggling with virtual learning, and they created what we have dubbed a pandemic poem, and I want you to check it out at some point in time, because this gave faculty and stakeholders a real sense of what students were struggling with trying to learn virtually from home in the spring of 2020. And so, as 2021 kept going on, it's not like our mental health issues didn't diminish. They got worse. The stress levels got worse, and so on, as they did for all of us. And so in the next slide, you'll see what we tried to do. So we know that the stressors of 2020 were big, and our students were struggling, and our faculty were struggling through this pandemic. And so we hypothesized that if we could just bring mental health discussions into the beginning of class or the end of class, remind them that we understand students are valuable, that they are, we know what they're going through, and we want them to understand that what they're doing and how hard they're trying is well known. And then the change idea was just to bring those little reminders into the semester, and also our students executed some mental health activities for the rest of the first 2 students, which was so amazing. They did yoga online and things like that. They brought in somebody to talk about mental health. It was really powerful. So this was a small idea to bring that up and make it part of our normal day-to-day talk, and to see if that would improve our students' outlook. And so in the next slide, you can see just a couple of quotes. We're still kind of in the process of looking at all the data. So what we do is you just ask, at the end, could you give us some feedback on these discussions? What do you think? Just to see if they're making a difference. And there are just a couple of quotes there. I really like the one on the left that says, I got to remind myself to have a growth mindset, that I can keep trying and keep learning. And on the right, to say, thank you for telling me I'm doing enough and I am being enough. So these are just a couple of quotes from the student feedback there. And so finally, in improvement science, I guess the big takeaway is, in the next slide, is that you first gather data by listening to each other. You try some things based upon what you hear, and you collect a little bit of data on that to see if you can get some evidence that what you're trying is making a tiny difference or an improvement in your course, in your whatever you're doing, wherever your locus of control is. And so an emerging theme in our network is, man, when we listen to each other, if I shut up now and listen to you a little bit, I'm going to get a lot more ideas about things that could improve the environment, improve the institutions where our students are really trying to be STEM people when they become adultier adults. So that is the conclusion of sort of the prepared remarks. We're going to turn this over to you in a minute, but I just want to know if you have any questions for Sean or myself, or anything that you'd like to comment on right now before we move on to the next segment. Okay, good. Erica's on the chat, so that's great. Anybody want to unmute and comment or ask a question about this kind of mechanism for improving things? All right. I see nothing. Normally I would wait longer. We all know about that little wait time technique, right?
Yeah, but sometimes get impatient,
I know. It's like program evaluation. It is. It's just quick. It's meant to be quick, and so that you can iterate more than once. So Sean and folks are getting feedback on this asset map, and that makes them iterate on it and so forth to make it better. And we're doing the same thing with the things that we're trying. So the next slide is sort of the next bit of this. So we have some minutes here, and we would like to have you reflect for a few moments on what current practices, wherever you work, whether you are in IT or administration or teaching or wherever you are. So what current practices in your own locus of control affect student success? And then if you can brainstorm some professional ideas that you might try that are small enough that you can actually do. They need to be something that can be done within your work and not something outside of that, and how you might measure whether or not that's having an effect. We'll ask for that as well. And so we don't even know if we've got the right breakouts here. So maybe in the chat you could tell us sort of where where your work is situated as part of this conference. But we have 3 Google Docs that we'd like to have you collaborate in a little bit. So do you want to tell us what y'all do?
Looks like if you go to the People tab, you can see
Oh,
a lot of their titles. We have some professional educators, special education teachers,
okay. Nice.
professor and chair of departments, instructional designer. Looks like a good mix of people.
Great. All right. Do you feel like you can jump into one of these 3? And we need to stick those in the chat, I guess, don't we? Stick those links in the chat.
I think Erica already has them in there.
Oh, great. Fantastic. I'm still navigating this system here. Technology and curriculum specialist. Yes. Well, yeah. Instructional designer. That's awesome. Sean, that's your people.
Yeah, my new people.
Your new people. Okay. Let's see. Well, just find a spot in a document. Find one of these 3 documents. I'm looking at, oh, there, I see them now, I think. And it doesn't matter which one you get in. We'll share all 3 of these. We'll compile these and just collaborate a little bit in there. We would be in some breakout rooms perhaps normally, but I think this will work. So head off to a document, and I'm going to go to administrators and see what I can see. There we go. Yeah, so just find a little spot that's somebody else. Good. I see the administrators has 1, 2, 3, 4, 5 people in it. That's great. Yes. And if you want us to go back to any particular slide, like the fishbone diagram or what the students have to say or anything like that, we can keep that up on the screen for you. If you'd like that, you can just let us know in the chat. I'm really glad to see this sort of mix of folks here. We're in our ending our 3rd year as an NSF alliance and really looking to broaden the diversity of our stakeholders. You all have unique perspectives that we need to hear from. So if we're very faculty and student-centered, would love to have you join the network and come to our conference and contribute your perspective. Sean and Erica, which document are you looking at?
I'm looking at the tech experts right now.
Okay. Good. Erica, are you an educator by any chance? Oh, she is. Okay.
I like the idea of a 24/7 help desk for technical issues. Just wonder how feasible it is manpower-wise. But definitely having some sort of system to intake those would be very beneficial.
Mm-hmm.
Oh, the alligator's telling me something. I love how you get all these animal names for Google.
Oh, that's great. So in the administrators group here, we're getting a comment about the WVU Advanced team that helps faculty in STEM create an atmosphere conducive to transformation. And dialogues help STEM departments have some of the difficult conversations related to diversity, equity, and inclusion. Yeah, and NSF felt like rural first-gen students were underrepresented as well, which is how we came to be funded to try this work, which is super cool. So that sounds like a program we want in the asset map in the hub at WVU Advance.
It does. I haven't heard of that one yet. I have a few of the WVU programs in there, but not that one. All right, looks like we got about 2 minutes. Is there anything else we want to look over, or we just want to round this up?
No, just you have access to these documents, y'all. So if you want to add in there anything you would like to share with us, we will read that and take that to heart. Our motto is to try to act on things that come our way. So we really do appreciate your time here. We can go to the next slide and just give our thank you slide there. And if you all have any comments for the chat or want to unmute, you go right ahead and do that. But thank you all for your time. We really appreciate it. And for learning a little bit more about First2 Network and improvement science. And I hope we get to work together sometime.
Thank you for attending our session, and a special thanks to our presenters, Suanne Hetherly, Sean Harwell, and Erica Harvey. Thank you.